Hi everyone, this is Dikshit. Welcome to my channel. In this particular video, we will going to discuss about DevOps scenario-based interview questions. And I would say this is a second video on DevOps scenario-based interview questions. I have already uploaded the first video. If you have not watched the video, please do watch it. I'm going to provide the link in video's description. And also, I'm going to answer all the questions with best of my knowledge. If you feel there is a better answer, do comment it so that whoever watches this particular video, they will get benefited. And also, this particular video can help somebody who's trying the job opportunities in DevOps area, or like who are already working in DevOps and they want to learn about different tools and different scenarios. For them, also, this video would be really, really helpful. And now, without wasting any time, so let's get started. The first scenario that I want to discuss is, let's say this is a configuration file that we have. And this configuration file that I want to copy it onto a bunch of machines. Now, in this particular slide, I have only 4 machines. Let's assume I want to copy this configuration file for 100 machines. And here, I don't want to copy this configuration file as is, but here you can see that there are 2 fields, which is node IP and node name. I want to replace the node. Let's say if I'm copying this particular configuration file to this first machine, then this machine's IP should be replaced. And also this machine's node name has to be replaced. And then only I want to copy this particular configuration file. Likewise, if I'm copying to the second machine, then the second machine IP should be replaced with this particular machine IP address and also the machine name. And then only I want to copy it to the respective machines. So if I want to do it for 4 to 5 machines, so then I can do it manually in a very easy manner. But if I want to do it for bunch of 100 machines, let's say, for example, even more machines, then it will be really difficult to do it over a manual activity. So that's where we can use some kind of automation. For this, we can maybe use the shell scripting where we can execute the commands to get the node IP and a node name, and then we can replace it in this particular configuration file, and then we can copy it. But let's say, for example, in future, you'll get one more request to install some tool or to copy one more configuration file. And also the nodes are the machines that we have of different types of OS. So then it is really difficult to deal with shell script itself. We can, of course, we can completely achieve it by shell scripting, but whatever the script that you are gonna write, it will be complex and also it will be really difficult to maintain it as well. So that's where in this particular situation, we can use the configuration tools like Ansible, Chef, and Puppet. In my case, I'm going to go with Ansible. By using Ansible, especially this particular scenario, can be easily achievable. So we have inbuilt variable. In Ansible, we will call the inbuilt variables, which are Ansible SSH host and Ansible hostname. By using this Ansible inbuilt variables, we can replace the IP address of a machine and machine name easily. And then by using template module, so we can easily copy any given configuration file onto the respective machines. And also we can replace the values and then we can copy it onto the machines. And the other advantages that we get by using configuration management tool is in future, if we get any requirement to install or to copy any file, we can easily do it by using Ansible. And if we have a machines, group of machines, which is combination of like different OS like CentOS, Ubuntu, Fedora, Debian, all those different OS machines, we can handle it very easily by using Ansible, the configuration management tool. And now let's move on. Let's discuss about the next scenario. The next scenario is related to monitoring. So I have one endpoint, which is https dikshitsn.com health status. What this endpoint does is it will going to give the health status of my microservices. Let's assume I have 5 microservices whose name is cart, UI, login, home, offers. And there will be a value associated with each microservice name. You can see that cart, if it is true, that means this particular application is healthy. And if UI is false, that means this particular microservice is down. So likewise, login, home, and offers, we have true and false. True means that is success, means the microservice is up and running. And if it is false, the microservice is down is what it does. But this particular output, whatever I'm getting is very raw. So the senior management would like to see it over a Grafana dashboards like this. If the application is healthy, so then they need to see okay. And if application is down or if it is not accessible, so then they want to show it as forbidden. So this is a dashboard they wanted, and they wanted it of Grafana because all other applications has been monitored here. So if we have this particular dashboard also in Grafana, so that they'll have one source of truth so that they can check the health of each and every microservice. But unfortunately, so Grafana can't directly fetch the data from a given endpoint and show the data into the dashboard. The Grafana can only accept the data from data sources like Prometheus and InfluxDB, and we have other sources like MySQL DB and other DBs it can accept the data from. But here to monitor this endpoint directly from Grafana, it is not possible, right? So that's where we can make use of the Prometheus. So here Prometheus, what we can do is from Prometheus, we can scrap the data from this particular endpoint. Prometheus easily can do these kind of activities, which can hit a given endpoint and it can scrap the data from that particular endpoint and give it to the destinations like Grafana, or it can send some alerts also. But here the problem is you can see that this particular endpoint is HTTPS. So Prometheus is efficient enough to scrap the data from HTTP endpoints, but not the HTTPS endpoint. It can do it, but you need to do a lot of like configuration. You need to provide the HTTPS certificate, key, so many things that you need to configure. It will add a lot of complexity in the Prometheus configuration. If you want to monitor any HTTPS endpoint. This is one issue. And also Prometheus expects the data in this particular format. Here you can see that this endpoint is giving it in a JSON format. So, but Prometheus can accept only data in this particular format. Key space a value, key space a value, like this, it will gonna expect. It can't accept any JSON, YML, or XML data. The data should be in this particular format. So then how do we solve this particular issue wherein I want to ultimately monitor this particular endpoint in Grafana and I want to see whether what is the status of each microservice. So that's where we can do one workaround. So ultimately the data should be stored in Prometheus and then only it can taken in the Grafana because it can accept the data only from few sources. So it should definitely go through from Prometheus itself. But to supply the data or to kind of convert this particular data into the Prometheus understood language, what we can do is we can create one pod. In my case, this is a solution that I provided. We can create one pod in Kubernetes cluster, and this particular pod will have two containers. The first container, I would take it as an init container, or like I would say this container will be running parallelly with my another container. I will going to tell what is the purpose of these two containers. The first container, what it does is, we will have a shell script, where in that shell script, we will have a logic to execute a curl instruction to against this particular endpoint. And when it gives this particular output, so I will going to use some commands and change this particular JSON into the Prometheus understandable language. And that particular output, I will going to store it in a specific file. Once I store it in that particular specific file, what I do is I will going to share, or like I'll going to put that particular file into some volume, empty directory volume. So on the other hand, so I'll have one more container where I will be running some Flask web application, which is developed by using Python. So where it's a web application, what it will do is it will gonna take the data from the first container, which has been created in this particular format. So it will gonna take that particular data and it will gonna be kind of like exposing one point. You can assume it as like HTTP UI app and else status. And this endpoint, so now it will be serving in HTTP, right? So what I can do, I can easily access this particular endpoint through Prometheus because it is HTTP, and also it is getting the data which is according to the standards of Prometheus, right? So now we can configure this particular endpoint in Prometheus. Prometheus can send the request at the regular intervals and get the data, and then it can store it in its time series database. On the other hand, from the Prometheus, Grafana can take the data and then we can create a beautiful dashboards like this. So this is a solution that I actually provided. So this is one of the use case that I came across, and also in some of the interviews they've asked this particular scenario, and if I'm there, this is how I will gonna implement it. But there are multiple ways also where you can implement this particular scenario. Let's move on to the next question. So in many of the interviews I've seen, they will be asking the error codes and different status codes of the pods in Kubernetes. And also, I've seen like asking the questions about how do we debug, what exactly the issue is, how do you see the logs, how do you see the events which are happening in the pod. So this has been the common question, and we have a lot of error codes in Kubernetes. So in this particular video, I wanted to discuss about few error codes which are very common in the Kubernetes application deployment. The first error code that I want to discuss is the create container config error. So this is a very common error. So let's say you have an application where you have Kubernetes manifest file, which is deployment and a service and also a config map. So when you have config map and secrets, especially before deploying the config map and secret, if you try to deploy the deployment, so then what will happen is it will be unable to find this config map and secret. In that particular cases, this create container config error you will gonna see. And also you can see that I've given one liner. The configuration specified for the container inside the pod is not correct or missing. In that particular case, this create container config error will come into picture. In most of the cases, before creating a config map or a secret, if you try to create a deployment, so this is an error that you will end up with. And then moving on to the next error code. So the next error code is a pending status. And this is also very, very common. In many of the organizations or in most of the projects, if it is a production grade project, what they will do is they will have a namespace concept. Each microservice to be deployed in a different namespace are like bunch of microservices. They will make sure that they will going to deploy it in a specific namespace. And also they will have a hard rule that every pod should have a resources block. So in the resources block, we need to specify what is a requested memory and CPU and what is a limit CPU and memory. All those things we need to specify. Let's assume you have a cluster where you have only a capacity or a pod you can accommodate with size 16 GB and 4 core CPU, but in your pod specifications, you have requested more. That means whatever the capacity of your cluster, you are asking more than that particular capacity. In that case, the pod can go into the pending state. You can see that whenever there is inefficient resources, so then Kubernetes throws this particular pending error. In another case, so let's say in your pod spec, if you have used any node selector, node affinity, or a pod affinity, if this affinity rules doesn't match, in that case also, you can see the pending state of the pod. And in some cases, I've observed whenever if your PV or PVC, if it is not there, in that cases also, the pending state of the pod will arise. And then moving on, the next error code that I want to discuss is OM killed. So out of memory killed. So this particular error, you will gonna see whenever a container or a pod, if it exceeds its memory limit or a CPU limit. So these kind of errors that you will gonna see. So in some cases, even I have observed when we deploy the application at the beginning, it will gonna up and running properly. And as and when the days goes on and the more request comes in, so the pod will get more pressure and whatever the CPU that you have assigned or like memory assigned will be exhausted. Due to that, it goes to this OM kill and the container will be kind of restarted. So that's where whenever you see this OM kill, that means the resources that you have provided for the container or a pod, which is not proper. So you need to kind of like consider increasing it or like you need to do some changes in your code itself, in some cases. So, but in usually whenever it exceeds the memory limit, OM killed error is what you will gonna see. And the next error code is crash loopback, and this is a very common error code that you come across a lot of application deployments. So this crash loopback error can be with a different issues. One is configuration. Let's say you have an application where it requires a proper configuration. If that configurations are not there, then the app won't come up. If the app is not coming up, what kubelet does is it will try to restart your container again and again and again. So when this restart happens, right, it will go into this crash loop back error. So that configuration errors also might cause this particular crash loop back error. And then we have resource constraints. So sometimes like when a pod is at the beginning, if it is running fine, and when it is the resources exhausted, first it will come to the OM killed, and then it will come to crash loop back error, and it will gonna kind of restart the container or a pod again by kubelet. That is what it will gonna happen. And it can be due to dependency and application errors also. Sometimes the developers, what they will do is the dependencies which are required for application to run are like the application code itself, they would have tweaked a little bit. So in that cases also, if application is not coming up, so that kubelet considers that the container has to be restarted. So it will continuously try to restart, and that's where the pod status will gonna stuck at the crash loop back error. In this case, definitely the logs or events will gonna be definitely helpful, and we will gonna see what are all the commands that we can use or we can execute to see the logs and events of the Kubernetes. And then the last status code or error code that I want to discuss is in some cases the pod will be in running state, but when we see the ready column, so it will be 0 out of 1. What does this 0 out of mean is out of one container. Inside the pod, you're trying to create one container. Out of one container, 0 containers are in a running state is what it does mean. Okay, so this issue most probably, so in some cases, while if the liveness probe, readiness probe, whatever you have configured, if it is not proper, so then it will be stuck at this particular status itself. The application will never come up. The pod will be running, but the restart count will be increasing, and also it won't accept any request which is coming up. Okay, so service, if service, if it wants to forward the request to the pod, so then the status of the pod should be running, and also the ready column in the Kubernetes kubectl get PO, that particular command's output, it should be 1 out of 1. Then only the request will be redirected to a certain pod. If it is 0 out of 1, then the request won't be redirected at all. So in most of cases, I've seen that liveness probe, readiness probe, they would have configured in the liveness and readiness probe the wrong endpoint. The developers would have been configured, or sometimes whatever the initial delay are like expected response time or timeout, those values that we configure it in liveness probe, readiness probe would have been very kind of low values. So that would have been caused to this particular issue. So in this particular case, what I used to do is, so first remove liveness and readiness probe, try to deploy the application. If the application is coming up, then I need to check what is the endpoint to check this liveness probe, readiness probe, health of the pod, basically. So I'm going to identify that particular one. And then after identifying that, what I will do is I will going to check what is the response time, what should be the initial delay, all those things I'll experiment. And then I will going to provide proper values to liveness probe and readiness probe. And to tackle especially the initial delay, we have startup probe in Kubernetes. We can make use of that as well. And then the other part of the question was, how do we debug? How do we find the issues? What exactly the issue? In Kubernetes, kubectl command line especially provides us two commands, which is kubectl describe pod and kubectl logs. By using kubectl describe pod and pod name, we can see what all the events are happening in the pod. So whether the new container has been created or what error it is throwing, all kind of events we can see. And kubectl logs pod name, when you give, you can see the application logs itself, especially if crash loop back error, if it comes, right? If we do kubectl logs and a pod name, so then we can see all the applications errors as well. Additionally, if the project is well established and if they have a bunch of good amount of pods, then definitely they'll have a logging mechanism. So by systems like ELK or monitoring solutions like Prometheus and Grafana, so there they will gonna store the logs and metrics. There also they can debug their issues, and they can try to avoid that particular issues in the future. Those are all the steps and things that we need to consider to make sure that the logs and the events of a particular pod, if you want to check. And not only these error codes are there, there are so many other error codes and like status codes in Kubernetes, but these are the common ones that I wanted to explain in this particular slide. And now let's move on. So let's discuss about the next scenario-based question. And this is also a very important scenario-based question, or a very basic scenario-based question that you get it in our interviews. Explain the complete CI/CD process that has been followed in your project. So before answering this particular question, so I need to share a few more things. Many people assume that there is a standard process for CI/CD. Every organization, every project, every client has to follow the same process. Many people assumption is that, but in actual scenario is the CI/CD process can vary project to project, client to client, organization to organization, and also it depends on what is the language that has been used by the development team to bring up the application or to develop the application. It depends really on all these kind of things. And there is no any set of standard that all CI/CD processes should have this particular stages or something. Okay, it definitely can vary client to client, organization to organization, and even within an organization, project to project also it can vary. Within project, team to team also can vary the CI/CD process. And now to answer these questions, I'm going to take two examples. I have worked on a couple of projects. So I'm going to take one embedded project of CI/CD process. The other one is like containerization project where we were deploying the applications onto the Kubernetes cluster. I will going to take that particular examples and I'm going to explain what are all the stages that we had. And also, before answering this particular question, you should also know the concepts like branching strategy. And also, if a project has artifacts, like if you want to publish any artifacts, so you should have a proper naming convention. You need to know what is a naming convention that you are using to push those artifacts, and especially in the containerization projects. So you need to know what is the Docker tag that you're going to use for each image that you're going to create. All these things you should have it in your mind, and then only you can answer the CI/CD process well. And now, as I mentioned earlier, I would like to explain two CI/CD processes. One is related to embedded project. The other one was related to containerization project. So in embedded project, so we had only CI. In that particular project, we have created only CI. So whenever a developer gets a new activity, so we had a rule that like he has to create a new branch, a feature branch, and then that was a branching strategy. So we had develop branch as a major branch. All the running code will be there in the develop branch. From the develop branch, he has to create a new branch, which we can call it as a feature. And whatever the feature is developing, he can give the meaningful name. Once the branch name has been given and branch is created, he can do his changes in this particular branch. And once his changes are done, he tested locally, everything is done, and he has a confidence that this code will work. Then what he can do is he used to raise the pull request. And so when he rises the pull request, so that's where we used to trigger Jenkins CI process. In this Jenkins CI process, we had a couple of stages. The first stage was clone stage. So once the clone is done, we had a parallel stage in Jenkins where we used to download all the dependencies which are required for us in build and testing stage. We used to download that particular dependency files. And once that is done, so embedded projects usually developed by using C, C++ languages. And we used to apply the static code analysis on C, C++ languages by using tools like CLang tidy. And once this is done, so if it is successful, then only we used to move ahead. If it is failure in any stage, so then we used to stop the pipeline there and we used to comment it on the PR saying that this particular stage has been failed. Take a actions on that particular failure is what we used to say. And also you can see that next stage is build stage. See, make builds that we were trying to do. And once the build is done, so we used to get some artifacts. Upon that artifacts, we used to execute unit test cases, integration test cases, and also we had some mock app where we can install this artifact which has been generated out of this particular build. And then we used to apply all the system integration test cases as well. Once this test cases has been executed properly, so that means whatever the code change has been done by developer, we were assuming that is correct because build has been done and testing has been applied. So once that is done, so we used to upload this particular artifact to JFrog Artifactory. So that is what we used to do it. And once developer gets the positive response from the CI, we had one more rule where the test team or like senior manager has to approve it. Because if there is a lot of changes, code changes, then test engineers, to be on a safer side, what they used to do is they used to download this artifact which has been uploaded from this particular CI run. They will gonna download it and then they will gonna install it on hardware, and then they will gonna test it out. All the smoke testing, they will gonna apply it and they will gonna test it. And if everything looks fine, so then they used to approve it. The testing team approval was mandatory in the pull request. Once this is done, then only the changes used to be merged onto the develop branch. And also, so now you can say this is a CI process. For a change, this particular pipeline was running. But where is the final artifact is given. So to avoid any a lot of complexities, so in that particular project, we had a very simple process. Whenever they want to deliver the final product that has to be installed on a hardware, so then we used to create a tag, and using that particular tag, we used to run the same pipeline again, download dependencies, static code analysis, build, testing. So once that is done, the final artifact that we created, right? So we used to give it to the kind of we used to say a flashing team. So that particular team will gonna take and then flash it onto the hardware. So this used to happen in this particular project. And as I mentioned, the other project that I was working on was the containerization project, and it will be totally different. When I say embedded project, we were having only CI, but the other project was containerization project, where the methodology or like stages were completely different. And whatever the pipeline are like stages that I've explained in previous embedded project was also there on the Jenkins, and the containerization project that I'd worked on, where we have created a CI/CD for that particular project, was also on the Jenkins itself. But now in the market, there are a lot of CI/CD tools like GitLab, Azure pipelines we have, and likewise we have GitHub Actions. If you take any CI/CD tool, the stages will be same. It's just that the syntax or different variables or handling the sensitive information might be different. But the pipeline stages will remain more. Like let's say in my case, I've implemented in Jenkins, but the same stages can be implemented in any CI/CD tool. Okay, so in this particular containerization project, so the same procedure, we had a proper branching strategy. Branching strategy was we had a base branch as a develop branch. All the development activity were used to happen in this develop branch, and whatever the code which is there in the develop branch is assumed as like the runnable code. That means at any given point of time, if we deploy with code which is there in the develop, that it will going to bring up the application without any issues was the assumption. And so whenever you developer wants to do the change, so then he has to create the branch. So here we had a different branching strategy where developer need to create a branch name with the ticket ID which has been assigned to him. So usually many teams now they go with agile methodology where they will going to use Jira as a tool. Here they will going to create the ticket for every small task, big task, or whatever it can be. They will going to create the ticket and then they will assign it to a specific developer. That specific developer, whatever the ticket he gets, right, with that particular ticket ID, he has to create the branch name. So this was a standard that we were following. So once he creates the branch with that ticket ID and he can do his changes in this particular branch, and once he gets the confidence that this code is working fine and you want to merge it onto the develop, so you used to raise a pull request, or in some of the SCMs we will call it as merge request. In GitHub we will call it as a pull request. So in first few days of the project we were using GitHub, and then later we migrated onto GitLab, and that's where we used to call pull request, which is in GitHub is same as merge request in GitLab. So that's why I have mentioned both pull request and merge request. Whenever developer raises a pull request or a merge request, it used to trigger a Jenkins pipeline. In the Jenkins, we have configured webhooks and all, so that used to trigger this particular pipeline, where we had stages like clone, and then the next stage was sanity check. So sanity check, what is the importance of this particular stage was, whenever developer raises a PR or MR, so many developers we have observed that they won't provide any information. So that's where we implemented this particular stage. What it does is it's gonna check the subject of the pull request, and also it used to check whether task ID has been linked for this particular PR or not, and also whether testing information has been provided or not. All these kind of things we used to check it. And if user doesn't provide, or a developer doesn't provide that particular information, that means we used to assume that the developer has not raised the pull request in a proper way. So we used to fail the pipeline, and we used to send the feedback to the developer saying that you have not followed the sanity rules. Please do follow it, as what we used to reply it. And let's assume developer has followed all the sanity rules. Then these are all the stages that we were executing. So downloading the dependency which are required for build unit test cases and integration test cases. And once this crashes, so here most of the containerization projects that we have worked, where the language that the applications were developed was Java and Node.js and React.js, where we used to use a Sonar Cube as a static code analysis tool. And so we used to execute this particular stage where we will going to check whether our coding is according to the standards or not. We used to have proper quality gates configured in SonarQube, and also webhooks enabled in SonarQube, so that we will gonna upload the report onto the SonarQube, and also we used to get the reply back from the SonarQube whether code quality is proper or not. If the code quality is proper, so then we used to proceed. If not, we used to give the feedback to the developer saying that your code quality is not proper. Please do correct that particular one. And let's assume if the code quality is good, so then we used to execute build, and then unit test cases, integration test cases. Once the integration test cases has been executed, so that's where we used to create Docker images. And here, very important thing that you need to remember is, so for every, you can see that there will be many. So whenever a pull request or a merge request is created, so obviously CA will gonna run on. And so if I have 10 developers, if 10 pull requests are there, 10 different images that I will be creating. So that's where if there are so many images, then I need to have a proper tagging strategy. I can't name every image with the latest tag, right? Let's say my image name is UI app, and I can't tag with the latest every image. So then I won't be able to store all the changes, or like are the images related to different developers, right? So that's where, so Docker tagging strategy is very, very important. In some of the pipelines, what we used to do is we used to tag the image name with a Jenkins build number. Let's say if it is a first build, then the image name used to be UI app :1. And if the build is fifth, so then the image name used to be UI app, and the tag is fine. And in some of the pipelines, they said that it will be helpful with whatever the commit that it has been triggered this particular pipeline. You can take that particular commit, and that particular commit, short commit, you can give it as a tag and push the images what they've requested. That also we have done actually. So this tagging is definitely depends on application to application, and depends on development team as well. Depending on the request, we can consider different tagging strategies as well. And then we used to tag that image, and then we used to push it to JFrog Docker image repository. And also, as this was containerization, we were deploying the applications onto Kubernetes cluster. And those applications to deploy, we were using Helm charts. In this particular stage, Docker build and also the Helm charts that will be part of the repository, right? That will be archived and will be pushed onto the JFrog repository. That also we used to do it. So once the artifact is pushed onto the JFrog, so then the next stage used to be Kubernetes deploy. And you can now ask me like, this is a CI, this you're running it on a pull request or a merge request. Why you want to deploy this incremental changes? So in our case, we were deploying it, and this was the ephemeral cluster. We used to call it as ephemeral cluster, where only the Jenkins or the CI tools will have access to this particular cluster, where it can deploy the new image which has been kind of created out of this particular CI, and it will going to deploy. And after deploying it, so we had a stage. We had a mandatory stage, which is API testing, where developer needs to provide some of the APIs, major APIs to test the application. we used to apply this particular test cases, and then we used to get the result. So by using these results, we can easily judge whether the new changes, the application is working or not. If it is not working, so then we used to send the negative response. And if this API testing works fine, so then we used to send the positive response. Obviously, we used to delete this particular deployment, whatever we did it in CI. And also in the ephemeral environment, we had a rule. Any pod, if it gets deployed, or like any deployment that we did, that will have an expiry of only 2 hours. If anything more than that, so we had some garbage job which was running inside my Kubernetes or ephemeral Kubernetes cluster itself. It was a cron job or a job where it used to check what is the time that the pod has been deployed, and if it is crosses 2 hours, then it used to clean it up. So this is how we're in CI/CD and a pull request we used to run. So by using these stages, we used to not only make sure that whether the code is buildable, we were also deploying it, and whether the app is coming properly or not. Also, we were checking in this particular CI strategy. And once, let's assume all these things are done, and the developer got the approval from his manager or a lead, so then the code will be merged from feature branch to the develop branch, right? So once any commit which gets merged onto the develop, again, we had commit based Jenkins job. So here also, there were a couple of stages. You can see that clone, download dependency, static code analysis. These are the repeated stages because already we would have ran and created an image, right? But again, we wanted to run the static code analysis. We wanted to check nothing is broken in the develop branch. And after that, we used to execute the build, unit test cases, integration test cases, and then create a Docker image, Helm chart, upload it onto the Artifactory. And then we had a stage which is called as approval stage. So this stage, if you want to really deploy that particular commit onto the dev environment, you can take the approval from a manager or a lead. Only few people had a authorization to approve it. So we can take the approval and it used to deploy it automatically onto the dev environment. If the approval is not given, so we had a timeout of 30 minutes. If it is approval is not given in within 30 minutes, then we used to abort the job. But the image and Elm charts used to be uploaded onto the artifact. Okay, so these are the stages that we had. Now you might have a doubt. So the verification on a pull request is fine, and also I have shown like how the dev deployments happens, but how the promotion to the higher environments will gonna happen. Let's assume QA and production. So that's where in that particular project, we had one more job where it will gonna ask the inputs like image name, Helm chart location, environment to deploy, and strategy to deploy, whether it is canary or a rolling update. So when we provide this particular application, so it used to run a pipeline where it has a stages like approval. So once this has to be approved by your senior manager or like a test lead, so or a lead. So if they approve it, so then so it used to connect to the respective Kubernetes cluster, whatever you have selected in this particular option. And then so here I've given dev, so it can be QA or prod as well. It will gonna connect to that Kubernetes cluster and apply the help check. And also we were kind of like creating a stage. So when I was there, when I left that particular project, it was still in development, where this stage wanted to check whether the new deployment has been gone through or not. If new deployment has been not gone through, automatic rollback we wanted to create. So this particular stage we were trying to create, but when I was there, where like it was still in progress. So I just wanted to add this particular stage where I wanted to say like so different strategies can be followed in different projects. That's what I wanted to show by using this particular pipeline. And also again, I'm repeating, there is no standard that these are the stages should be mandatorily there in CI/CD. It's up to the development team. It's not development team. It is up to the management, what they want to have, which stage they want to have, what is the importance they want to give. All those things, it depends on project and the leads are architects who work on that particular project. And then moving on, I would say the last question on this particular video. So let's say, for example, I have an application which is deployed on a Kubernetes cluster. And so development team has followed all the best practices. They've use distro-less images and slim images, and they've developed the Docker images, and then that has been deployed on a Kubernetes cluster. This is all good, and the application worked very efficiently for a few days. But after a few days, they see that a lot of errors. So to see those errors and to debug that particular issues, they used kubectl describe command, and they've used kubectl logs command. But unfortunately, they couldn't get that much information using that particular commands. Now, what they want is they want to log into the pod, and they want to really check a few of the processes whether which are running or not, a few of the endpoints which are active or not, and they want to see some files which has been created properly or not. So those are the things they want to check it. But unfortunately, they have followed the best practices like distroless, slim image, and also they have ran the container with a non-root user. So they are not able to kind of log in, because in slim images and distroless images, the shell itself would have not installed, and some of the utilities like curl and the ps or netstat commands utilities might not be available. So due to these issues, they're not able to log in, and they're unable to check these kind of configurations, are like the health checks. They're not able to do it. So can we do any workaround, or like is there any way where we can get into the pod? The answer is absolutely yes. From the version 1.16, the Kubernetes has introduced a concept which is called as a ephemeral containers. So ephemeral container is one more container. So you can attach it to the already running container by using this particular command. You can see that kubectl debug IT and the application pod name, and then the image. So this is the ephemeral container image. So what it does is it simply creates one more container with this particular whatever the supplied image, and with that supplied image, it'll gonna connect to this particular application container. That is what it does actually. And in this ephemeral image, we can install whatever the utilities that we need, and then we can basically execute, and we can check the files, all those kind of things we can do it. Okay. So this is the best way wherein we can still keep application container image as small as possible. And whenever we want to debug, so then only we can create this ephemeral container and connect to application container. And there are so many disadvantages if you install all the required tools. So then what happens is like it can increase some security vulnerability also. So that's where you should have only whatever the tools and dependencies which are required for the application. Only you should have that, and you should bring up the application container. So in case if you want to debug, so then kubectl logs, kubectl describe commands are there. And now in Kubernetes, we have an option which is ephemeral containers. You can use those concepts as well. And yeah, so that's it for this particular video. These are the questions that I wanted to discuss. And if you've liked the video, or if you feel that the information that I've shared is useful, then please like, share, and subscribe to my channel. So thank you. Have a great day.